Compton scattering of a photon by a moving electron. Consider Compton scattering of a photon by a moving electron. Before the collision, the photon has wavelength lambda and is moving in plus x direction, and the electron is moving in the minus x direction with total energy capital E, including its rest energy mc square. The photon and electron collide head-on. After the collision, both are moving in the minus x direction, that is, the photon has been scattered by 180 degrees. Part A. Derive an expression for the wavelength lambda prime of the scattered photon. Show that if E is much greater than mc square, where m is the rest mass of the electron, your result reduces to lambda prime equals hc over E, capital E, parentheses 1 plus m square c to the fourth power lambda divided by 4hc, capital E. All right. So we have the incoming photon energy hc over lambda, and then we have the electron energy E. The scattered photon has energy hc over lambda prime. The scattered electron has energy E prime. This is my energy conservation equation, and I'm going to call this equation 1. So we need lambda prime as a function of capital E and lambda. That's the equation we're after. The momentum conservation, everything is happening on the x-axis. So we have the incoming photon momentum h over lambda. The electron is moving in minus x direction, so minus gamma mv is its momentum. And then they get, the photon moves in minus x direction, minus h over lambda prime. And then we have the electron moving in minus x direction, minus gamma m v prime. That is the momentum conservation equation, and let's call this the second equation. All right, and let's call the incoming photon momentum P, which is h over lambda, and the scattered photon momentum P prime, which is h over lambda prime. The electron momentum capital P, gamma mv, that's the initial momentum, and final momentum capital P prime is gamma m v prime. Okay, now going back to the energy conservation equation, hc over lambda, we can write pc plus the incoming electron energy, capital E, is equal to P prime C, the scattered photon energy, plus capital E prime, the scattered electron energy. And we know that E prime can be written as P prime C square, capital P prime C square, plus mc square square root. And we know that the total energy of the photon can be written as the total energy of the incident electron can be written as capital PC parentheses square plus mc square 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 root. So we can write this for the total energy. The second equation, the momentum conservation equation, tells me the incoming photon momentum P minus the momentum of the electron, capital P, is equal to minus P prime, the scattered photon momentum, minus capital P prime, the scattered electron momentum. So for the actually from this equation here, we can pull out m squared c to the fourth power. So m squared c to the fourth power is equal to capital E squared minus capital PC squared. This is what I'm going to call equation number 3. So let's keep that in mind. And going back to the energy conservation equation, PC plus capital E is equal to P prime C plus capital E prime. For capital E prime, I'm going to substitute P prime C plus capital P prime C square plus MC square parentheses square square root. So I've just substituted this for capital E prime into the energy conservation equation, and taking P prime C to the left hand side, I have PC minus P prime C plus capital E parentheses squared is equal to capital P prime C parentheses squared plus MC squared parentheses squared. And from the momentum conservation equation, this equation, I can take P prime to the left hand side and the rest to the right hand side. So this gives me capital P prime is equal to capital P prime is equal to minus P prime plus P minus P. So P plus P prime minus P is equal to minus capital P prime. So if I take these to the left hand side, P plus P prime minus capital P is equal to minus P prime. Okay, so going back to my energy conservation, this equation here, I'm going to write this as PC minus P prime C plus capital E square is equal to so that's the left hand side of this equation. And here I have P prime C parentheses squared plus MC squared squared. For P prime C, I'm going to substitute this result here. So this can be written as PC plus P prime C minus capital PC squared, since it's the squared, it doesn't matter if I have the minus sign or not, plus mc squared squared. So I have substituted for p prime c this equation multiplied by c. And since it's the square, the minus sign doesn't matter. So this gives me capital P c parentheses squared plus p prime c parentheses squared minus 2 c squared p plus p prime capital P plus m squared c to the fourth power, and that is for the left hand side. I have this part, so that I can expand as well. P minus p prime c parentheses squared plus e squared plus 2 capital EC p minus p prime. That's the left hand side of this equation. And for the right hand side, I have if I expand this further, p square c square plus p prime square c square and minus 2p p prime c square plus e square plus 2e pc minus 2e p prime c. So that's basically what I have here. P squared c squared plus 2p prime p prime c squared minus 2p p prime c squared plus e squared plus 2epc minus 2ep prime c. That's the left hand side of this equation. That's this part. This must be equal to this part, and that's equal to capital P squared c squared plus, now I'm expanding this part, p prime squared c squared plus 2p p prime c squared plus p squared c squared minus 2 capital P c squared p minus 2 capital P c squared p prime plus m squared c to the fourth power. So I worked on the left hand side of this equation and the right hand side of this equation, where I have substituted for p prime this result. Basically that's the right hand side I'm expanding, and when I compare these two sides, I realize that p squared c squared and p prime squared c squared cancel out from the left hand side and the right hand side. So let's rewrite what I have left here. E squared plus 2 capital E c p minus p prime minus 4p p prime c squared minus capital P squared c squared plus 2 capital P c squared p plus p prime minus m squared c to the fourth power is equal to 0. So basically, I have this term, e squared, and then I have 2ec p minus p prime. So here I have 2ec p minus p prime, that term. And then I have this taken to the left hand side, minus 4p p prime c squared. And then I have minus capital P squared c squared. And then I have this term 2pc squared p plus p prime taken to the left hand side, this becomes plus, and this term taken to the left hand side minus m squared c to the fourth power is equal to 0. And here I'm going to substitute equation number 3. So this will be substituted here. So let's see what I get. Capital E squared plus 2 capital EC p minus p prime minus 4p p prime c squared minus capital P squared c squared plus 2 capital P c squared p plus p prime minus capital E squared plus p squared c squared is equal to 0. So that's basically what I had here in equation 3. Now you can see that I have further cancellations here. Capital E squared cancels, and then I have capital PC squared canceling out. So I'm left with, let's see here, and you can see for the terms that are left over, I have 2, 4, and 2, so I can divide it by 2. So I'm left with capital EC p minus p prime minus 2p p prime c squared plus capital P c squared p plus p prime is equal to 0. I can also divide this by c. I will obtain capital E p minus p prime minus 2p p prime c plus capital PC p plus p prime is equal to 0. Now let's take this into p prime parentheses. P prime parentheses, I have capital PC here. Here I have minus 2pc, minus 2pc, and then here I have minus capital E. And then the leftover terms in p parentheses, I have capital PC plus capital E is equal to 0. So that means I can write p prime as p times capital E plus capital PC. So this goes there with a negative sign, but if I multiply this equation by minus 1, basically I would get 2pc plus E minus capital P C for P prime. Now P prime is H divided by lambda prime. This is equal to P, which is H divided by lambda. And then here I have capital E plus capital P C 2pc plus capital E minus capital PC. So this tells me that lambda prime can be written as, if I take the reciprocal of both sides, lambda times 2pc plus capital E minus capital P C divided by E, capital E plus capital P C. And I know that P is equal to H over lambda. So if I substitute that here also, I find lambda prime is equal to lambda times E minus capital P C. So here I'm substituting H over lambda. So lambda times E minus PC plus 2HC divided by capital E plus capital P C. So here I substitute H over lambda. So that's going to multiply this by lambda. So 2HC is what I'm going to get. Lambda times E minus PC and divided by lambda times E plus PC. But there's another lambda here, so they would cancel out. So this would give me my final answer for lambda prime. Now, the problem says